Today we are going to see big data technologies. What are technologies used especially for handling big data? Uh, Before that, let us see some uh, about distributed and parallel computing, especially for big data. Distributed computing is a method in which multiple computing resources are connected in a network, and the computing tasks are distributed across the resources, thereby increasing the computing power. Distributed computing is faster and more efficient than traditional computing, and hence immense value when it comes to processing a huge amount of data in a limited time. To carry out complex computations, the processing power of standalone personal computer can also be enhanced by adding multiple processing units which can carry out the processing of complex tasks by breaking it up into subtasks and carrying out individual subtasks simultaneously. Such systems are often termed as parallel systems. The greater the processing power, the faster the computing. Distributed and parallel computing. Let us see one by one what are their difference between. Distributed computing system is an independent autonomous system connected in a network for accomplishing specific tasks. Whereas parallel computing system is a computer system with several processing units attached to it. Coordination is possible. Distributed computing system coordination is possible between connected computers that have their own memory and a CPU. In parallel computing system, a common shared memory can be directly accessed by every processing unit in a network. Distributed computing system allows coupling of computers connected in a network that provide access to data and remotely located resources. Parallel computing system tight coupling of processing resources that are used for solving a single complex problem. Introduction to big data technologies. A big data system is vastly different from other solution providing systems, and it is based on 7 V's, namely volume, velocity, variety, veracity, variability, value, and visualizations. Volume in terms of big data, datasets can be order of magnitude larger than traditional datasets, which demands more thought at each stage of the processing and storing life cycle, often because the work requirement exceeds the capability of single computers. This becomes a challenge of pooling, allocating, and coordinating resources from groups of computers. The other characteristics of the big data is velocity. Data is frequently flowing into the system from multiple sources, and it is often expected to be processed in real time to gain insight and updated current understanding of the system. These focuses need instant feedback as driven many big data practitioners away from batch-oriented approach and closer to a real-time streaming systems. The other is variety. Big data problems are often unique because of the wide range of both the sources being processed and their relative quality. Data can be ingested from internal systems like applications and server logs, from social media feeds, and other external APIs, from physical device sensors, and from other providers. Veracity. The variety of sources and the complexity of the processing can lead to challenge in evaluating the quality of data and consequently the quality of resulting analysis. Value and visualization. Value. The ultimate challenge of big data is delivering value. Sometimes the system and the process in a place are complex enough that using the data and extracting actual value can become difficult. So, introduction to big data technologies, a system that complies with this property and happen to be robust to withstand unexpected event and scalable enough to accommodate features methodologies in qualified to be called as a big data system. A typically big data system consists of setups that adhere to these seven V's and provide a great infrastructure that can be withstand the influx of huge datasets with high velocity, meanwhile providing effective mechanism to process the datasets by cleansing, shaping, filtering, sorting, and meaningful information aimed towards making the data both users and machine friendly. Hadoop big data technology. One of the big data technologies is Hadoop. Hadoop is an open source platform that provides analytical technologies and the computational power required to work with such large volumes of data. Hadoop platform provides an improved programming models which is used to create and run distributed systems quickly and efficiently. Hadoop cluster consists of single master node and multiple worker nodes. The master node contains a name node and a job trackers, and the slave or workers node act as both data node and the task trackers. Hadoop requires Java runtime environments higher version. There are two main components of Apache Hadoop: the Hadoop distributed file system and the MapReduce parallel processing framework. Hadoop distributed file system is a fault-tolerant storage system in Hadoop. It stores large size of file from terabyte to petabyte across different terminals. Data is replicated on 3 nodes, 2 on the same rack and 1 on the different rack. The file in HDFS is split into large block size of 64 or 128 megabytes, and each block of the file is independently replicated in multiple data nodes. The name node actively monitors the number of replicates of a block by default 3 times. When a replicate of block is lost due to data node failure or disk failure, the name node creates another replicate of blocks. The other big data technologies are R is an open source programming language and an application environment for statistical computing with graphics developed by R Foundation for Statistical Computing. It is an interpreted language like Python and uses a common like interpreter that supports procedural as well as generic function with object-oriented programming. R is extensively used by data miners and statisticians, providing a vast variety of graphic and statistical techniques with linear and nonlinear modeling, time series analysis, classical statistical clustering, classifications, and others. R is easily extendable and implementable through functional and available extensions. Cloud computing and big data. One of the vital issues that organizations face with the storage and the management of big data is a huge amount of investment to get the required hardware setup and software packages. Some of these resources may be overutilized or underutilized with varying requirements over time. We can overcome these challenges by providing a set of computing resources that can be shared through the cloud computing. The cloud computing environment saves costs related to infrastructure in organizations by providing a framework that can be optimized and expanded horizontally. Features of cloud computing. Cloud computing is scalability, cloud computing is elasticity, cloud computing is resource pooling and self-services and low cost and fault tolerances. Cloud deployment model. Cloud, public cloud or end-user level cloud, a cloud that is owned and managed by companies, and one which can be either an individual user or a company using it is known as a public cloud. The other is private cloud, enterprise level cloud, the cloud that remains entirely in the ownership of the organizations using it is known as private cloud. The other is community cloud. Community cloud is a type of cloud that is shared among various organizations with a common tie. The other is hybrid cloud. The cloud environment in which various internal or external service providers offer services to many organizations is known as hybrid cloud. Cloud delivery models. Cloud delivery models infrastructure as a service. It is one of the categories of cloud computing services which makes available virtualized computing resources on internet. Platform as a service. Platform as a service, it is built above infrastructure as a service and is a layer that interact with the users, allowing them to deploy and use applications created using programming and runtime environment platform that are supported by the providers. Software as service. Software as service is one of the most popular cloud-based models and comprises applications provided by the service provider. Cloud providers in a big data market providers have been gearing up to bring the most advanced technology at competitive price in a market. Some providers are established, whereas some of them are relatively new to the field of cloud services. Some of these providers are rendering services that are relevant to big data analytics only. Some such providers are as follows: Amazon, Google, Windows, others are some providers of cloud. The other is in-memory technology for big data. Hardware abstractions and the limitation lack of memory indifference have to be sidelined and streamlined with something faster like a cache memory or dynamic access memory so that the data is readily available for disposal. The in-memory big data computing tool supports processing of high-velocity data in early time and also faster processing of the stationary data. Technology like event streaming platform in the memory database and analytic and high-level messaging structures are witnessing the massive growth that resonates with the organizational needs for better understanding is achievable by the wider and deeper data assessments. Let's sum up. The distributed computing work on the role of divide and conquer, performing models of the parent tasks on multiple machines and then combining the results. Parallel computing refers to the utilization of single CPU present in a system or group of internal coupled systems by the means of efficient and clever multi-threading operations. Distributed computing is considering as a subset of parallel computing, which further is a subset of concurrent computing. A big data system is vastly different from other solution providing systems and is based on the 7 V's, namely volume, velocity, variety, variable, value, and visualizations. A big data system is vastly different from other solutions providing systems and based on the 7. This is all about big data technology. Thank you.